but for this ice cube, it's melting!
Ice is the solid form of water. Solids have a definite shape and volume. In order for ice not to melt back into water, it has to be in a place that is cooler than 0 degrees Celsius or 32 degrees Fahrenheit, the melting point of ice, where it begins to turn into water. Melting is not an instant process, so let's put it in this glass and check back on it in an hour.
Dimethyl siloxide will be freezing now.
But sometimes you want something frozen. Like ice cream. Maybe that's true for dimethyl sulfoxide. Look at all this liquid in the cup! Liquids, as you can see, have no definite shape, but actually do have a definite volume. An hour ago, there was no liquid in this cup, and it was like a solid with a definite shape and volume. How did this happen?
Since the temperature outside is above 0 degrees Celsius, the temperature water has to be to remain in the solid state. It will turn back into a liquid.
Is that the only change that can happen to water?
Not at all! You can put this water back in a place below 0 degrees Celsius, so it can freeze back into the solid form, which is ice. You can also heat water to its boiling point, 100 degrees Celsius. Once water reaches the boiling point, it cannot get any warmer, but it will turn into a gas in a process called vaporization. Let's display vaporization now. The heat is on under this water. When the water starts bubbling, that means the water is at its boiling point and will start turning into gas.
Isn't boiling what you use to cook foods like pasta?
Yes, it is. Due to the temperature, the movement of particles, it is sometimes the best way to cook food. When cooking, if you see steam, that is water in the gas form. Since it's a process that takes time, not all water goes at once.
Okay, that makes it clearer.
Some say a washed pot never boils, but that's not true because this pot is now boiling, and it's been only 9 minutes.
You want a shot of the boiling? Okay. That's just a saying. Now that we've seen boiling, what else is there to see?
There's also sublimation and deposition, the change between a solid and gas without passing through the liquid state. That's deposition. When sublimation occurs, the pressure and temperature is so intense that no liquid state is needed. Deposition is the opposite of that.
That is extraordinary. What temperature is needed for that?
Even though with water it needs to have extreme movement of particles through boiling, the opposite is true for sublimation. Dry ice, the solid form of carbon dioxide, which we do not have with us today, needs to be a very chilly 78.5 degrees Celsius in order for sublimation to occur. Another time sublimation could occur if you hang a wet piece of clothing outside on a below freezing day. Eventually, there will be no water. Sublimation is very hard to see.
Is there an opposite of boiling?
Yes! Condensation is the opposite. Condensation is the process in which water vapor turns into liquid water. Condensation is responsible for glasses fogging up or the liquid outside of a glass of a beverage.
That's why my glasses are fogging up.
Exactly. The states of matter are very important to us every day. You can see all the states of matter in a beverage. You can see the ice cubes, which are solids, the beverage itself a liquid, and condensation on the outside of the cup, which is gas turning into a liquid. Not to mention even that things like ice are frozen and that they're melting in it.
I never noticed that, but now I know. And knowing is golden.
Thank you for following our voyage of solids, liquids, and gases. I hope you found this informative. Thank you!
Thank you.